Hello there, welcome once more. Today we look at three dimension. It's a topic in Form 4. If you're joining us for the very first time, kindly subscribe. So we have a question here. It is on three dimensions. So we are given the figure below shows A, B, C, D, E, F, G, H. Find the length AC. So AB is 8, BC is 6, and CF is 4 centimeters. So AC is actually the diagonal. So we apply Pythagoras theorem to solve AC. So AC is the hypotenuse in that triangle that is formed where at point B, that is where we have angle 90. So therefore, we just sketch the question there, and then we'll apply Pythagoras theorem. So C squared is equals to A squared plus B squared. So therefore, AC is equals to 8, the square root of 8 squared plus 6 squared. Then we get this is 64 plus 36, which is 100. The square root of 100 is 10 centimeters. Then we move to AF to 2 decimal places. AF we can clearly see it. Again, we'll use the diagonal, which already we have, and the height CF. So AF again is our hypotenuse for that matter, while AC is our base, the 10, and FC is our height. And at point C, that is where we have angle 90. So again, AF will be 10 squared plus 4 squared. AF will be 10 squared plus 4 squared, the square root. So we get this to be 10 squared plus 4 squared which is 116. So the square root of 116, 10.77. So root 116 is 10.77 centimeters to 2 decimal places as the examiner required us to give the answer. So then we move on. The angle AF makes the plane AF makes with ABCD to 1DP. So AF, plane AF, or the angle AF makes with the plane ABCD, actually the base. So we are going to consider that triangle ACF. So that angle there, angle FAC, is the angle in question. So using that triangle, we had AF, then we have down there we had our 4 and our 10. So we are looking for that angle. So we can call it theta. So according to trigonometric ratios, the SOHCAHTOA, these actually going to use the tan. So opposite over adjacent. So tan theta is be 4 over 10. And therefore theta will be tan inverse 4 over 10. Feeding that to the calculator, we get angle theta. So tan inverse 4 over 10. It is good to introduce the bracket to avoid messing up. So this is an 21.8 degrees 80, and because we asked to 1 decimal place, that 0 should not be there. So it is that 0. The angle plane AEFD makes with the plane ABCD. So those planes, the point where we have their centers is actually where that angle will be formed. So the plane in question is actually slicing the cuboid into two halves. So we can see AB, then EF, and then the base. So we are considering, that is the path, and the base, which is height remains to be 4. The base is actually the 6, since it is the breadth, and the height is 4. So again, we call that angle phi. So therefore we say, again we use tan, considering that triangle, we have 4, we have the 6, so we use phi. So we say tan phi is equals to 4 over 6, and therefore phi is equals to tan inverse 4 over 6. And this is actually, so tan inverse 4 over 6, we get 33.69 to 2 decimal places degrees. And finally, we have find the angle between line EG and line DC to 2 decimal places. Line EG, to OC. So we are going to drop that line EG to become line DB. We drop it, so that's the only point, because line EG, its Q line is line DB, and therefore we are talking about angle at point D. So our 90 is at C, and therefore we call it angle beta, and therefore we say tan beta is equals to 6 over 8, and therefore beta is equals to tan inverse 6 over 8, which is equals to 36.86 degrees. So we talk of 87 degrees to round off to 2 decimal places, and that is 10 marks. So if you are yet to subscribe, kindly do so.